In the world of T2, where the source is king, build a custom Linux like the Freedom Ring. From ARM to Android basics, risk find in sight. Optimize for power all day and night.
Welcome everyone to another breaking news edition live here on this channel. The last time people, developers erected a logic for me pointing out what bugs they introduced. So today a vastly more positive spin. Thank you thank you ARM and IBM for breaking the Linux kernel, especially on SPARC64. Thank you for the privilege for me to spend over 20 hours last week to bisect the Linux kernel. Thank you so much. You are awesome. It is amazing. But don't take it from me. Just read here Linux kernel Debian developers, Adrian and others. According to posts here from us, allegedly maybe more stable than Spark is for broken, right? Figured out stability problems. Like, yeah, we bisect stuff day and night and figure out stability problems. So even according to Debian developers, don't take my word, take Debian developer word. There have been regressions on all the Spark systems, on all Spark systems, by the way, not only Order. Around 4.19. Also, basically Spark, I don't know what other Linux distributions doing. I'm not supporting SPARC64 anymore, only SPARC64, because like it is entirely unusable, right? Like how much are we talking? Debian developer say since 4.19 it's not amazing anymore. I also wonder like why are we recurrently live here on Twitch and YouTube the last to bisect all this stuff. Debian knew for ages it's broken, and like what I usually do, like if I find it's broken, I bisect this, which what we've done, right? So here's a result, right? So we did this live on Twitch, 4 hours there, 5 hours there. In the meantime, it's tested and broken. So I will not repeat the boring process of bisecting this, right? This is you could guru meditate and debug that with a kernel debugger and step through this. The problem is if your kernel is randomly memory corrupting or otherwise shutting off, halting, rebooting, resetting, there is not like single stepping John Carmack style. That is why most professional long-term Linux kernel developers resort to like, let's bisect this. It was working, and of course if you write a new kernel then you single step through that, but like with millions, billions of operations, mapping pages and so on, that is not like what you single step, right? You single step like once you develop some memory management code, like, and once it's working, or then stability testing and hammering it. But once, even if you write a new kernel from scratch and you have instabilities, that is some severe and night-long, week, month, year-long guru meditation, right? Some Linux kernel bugs only being found after years. So this is how this usually looks. That basically the new kernels, like how bad is people trying to run T2 or Debian on SPARC64 hardware probably know it's a little bit better on Sun 4V, but probably only for like it's only a little bit better, not as visible, but basically a non Sun 4V virtualized system, it's nearly impossible to boot, right? You boot 10 times or 20 times, maybe you can successfully boot once, and then it crashes quickly, right? Like if you're lucky, like sometimes you get an uptime of hours. Like we are talking, it's nearly impossible to boot, and if it's up, it crashes within minutes or hours. This is how it usually looks, right? Unable to handle kernel, null pointer, dereference, here some random crap, UDEF, whatnot. So if you want to watch all this stuff, you can go over to my Twitch channel. You might still find some archives there from the last weeks. It is boring stuff of git, bisect, start, good, bad. And the problem is it took over 20, or maybe it took even 40 hours, right? People think I over-exaggerate. I did not even live stream everything, right? Why is this so error-prone? Because this is not a bug that always occurs. It's like you need, like, when this started, like around 4 whatever, it was not that bad, right? So that is you could like boot 9 times out of 10, right? This is why every developer likes bugs, like there is a bug and you can reproduce it. Like basically every developer and quality assurance tester and developer wants reproducible bugs, reproducers. And so this is like you use it and it crashes. And the newer the kernel, the more it broke. And this probably way over 20, maybe 40, whatnot hours, 2 bugs, right? I could not believe, and these are the most, I expected from the beginning. I said probably some SPARC memory management, page handling and whatnot. But the bugs are the most crazy, like the most stupid bugs I've ever seen. The first bug was this one here from ARM, right? We like. Do you even know? Good that you don't see this, because there you see this. So this is ARM, but don't blame the developer. They did amazing work. Thank you so much for contributing to the Linux kernel. You rock. You're awesome. Unfortunately, it has some bugs. So this is I can't believe this is regression. So file system. This is, I expected SPARC. This is also why we bisect this and not like poke around in SPARC memory management stuff, because this is file system handle intra-page faults and copy. This copy, like improving copy mount options. What does it do? This is when you mount, when your user program mount runs and supplies with the mount system call, the mount options like read only, compress, equal, set standard, right? Like this string of options takes a user pointer argument but no size, and it tries to read up to page size. However, copy from user is not guaranteed to return all the accessible bytes. So it's basically probably only if like larger than page sizes on ARM64 with MTE enabled some memory trace, whatnot stuff. And so this tiny patch, like this is all it is. Like this is literally the patch. I've not yet gourmeted it. The other bug. So basically, this small change of copying it slightly more and safer and stuff caused random memory corruption in SPARC. I have not yet gourmeted this, like share, like, and subscribe, Patreon. Like basically 40 hours is not enough. I need to gourmet this. The good thing is this patch reverts cleanly on top of even the latest 6.10. So basically for SPARC we just revert this, and that improves stability. This is also why this usually happened on boot, because like this each time something was mounted, some page table memory corruption occurs. Like basically the more, and on mount we mount dev proc this temp and then the root file system. So basically some page memory byte corruption stuff. Yeah, it is stupid. It is what it is. I'm only the messenger, right? But the second thing is as silly, even more crazy. The second thing I can explain you nearly precisely or mostly why it works, fails. And the problem, in my opinion, is this fast forward and not testing, right? Sure, maybe this even is a bug that corrupts memory on other architectures, but that's also what I call out of this fast and break things Linux kernel developer model, where they always said, like, we can constantly clean up things and people will test it. Yeah, people test it, and yeah, it's more unstable every year. Basically, go use T2 Linux. Like, yeah, okay. The other problem is bisecting this, because this was so fuzzy. I sometimes bisected in the wrong binary partitions of the problem space and wasted 2 hours until I realized, like, darn, on this was wrong. This were like so many accumulating bugs that I had to redo the bisecting. So yeah. The other bug is this one from IBM fame, but thank you so much for this contribution. You make the Linux kernel so much more amazing. Totally not a bug, but a feature, and I thank you so much that I had the pleasure to bisect this all with you live on Twitch. This here is memory. Actually, this is memory management subsystem, a new exec memory architecture convert, simple overrides, and this bug is way more unstable. Like this caused the majority of why latest kernels nearly never boot on SPARC. And this bug is really, really crazy. So several architectures override module alloc. So the thing is, in the Linux kernel, we have multiple different memory regions. Like all this stuff is separated in managed by pages. It's page memory management. Probably should have opened some Wikipedia thing to show you some pages, like usually 4K or multiples 8K and huge pages and stuff, right? Do they not have a nice graphic? No, whatever. Pages, you can read this there. And several different regions exist, user space, kernel, and also different execute, read only, write data and code and stuff. So this provides a generic implementation in Execmem that uses a parameter for address space regions requiring alignment and page protection provided by architecture. The architecture must fill in Execmem info structure and implement Execmem arch setup and so on. So what this does, so they do this, totally amazing. Thank you so much, IBM. Highly appreciate your contribution making the Linux kernel exec memory management more flexible and so on. And also taking the time to convert SPARC for that. That is so amazing. Unfortunately, that has a tiny little bug that was waiting for me to be found. That is so amazing that I'm allowed to be the discoverer of this archaeological artifacts here in the Linux kernel. Introduced, by the way, in 2024, just recently, right? May 5th, 2024, so a very, very recent bug here in our stone age of kernel development. And so what this one I guru meditated longer, and this actually can fix for real. So as you see here, this is some Execmem. So what this does is they refactor this so that they can reuse the same code that previously they had for modules, because what modules are loading data from disk and mapping this in memory and then marking it executable with all the TLB, translation local site buffer flushes and so on, not to cause memory corruption, and be executable. And they reuse this, like basically unifying this code. Previously they had memory and the new in-kernel JIT, because obviously a single address space monolithic Linux kernel needs just-in-time compilation in the kernel. So to be able to like refactor this code and only do this once, they introduced here a new exec memory facility and converted here the architecture. So this is this is a long arch, and then we also have SPARC here. Excuse me, MIPS and SPARC, and so all of those are converted. There is some generic here in memory management init, execmem init. So this is just some region here, execmem. Here's some various regions. These are those execmem default and very potentially other regions that might exist. They mostly fill only this execmem, like this default region. These are like modules, like basically this is modules. So previously what happened is that this architecture over C++ like overrode here, virtually overrode in C this memory allocation for module alloc, this weak alias or whatnot, or actually not a weak alias, this is probably simply says defines this in a header, probably if dev module v address or whatnot. Anyway, so they redefined this of like, yeah, we need to do this like VM alloc in kernel node range size 1 between v address and modules end for GFP kernel range, contrast to user and stuff, page kernel, NUMA, no node, built in, this is just some function pointer thing there. So they convert this, right? And the new facility is that one here, right? Like this is simply execmem init missing. So this is on initialization run here, execmem init, validates here the region supplied and initializes this missing for once on boot, initializing the structure if the architecture didn't define this. So this is for between default and execmem type max if there are multiple others, just copying this over like if this was not defined by the architecture. Okay, so far so good, right? And here is somewhere execmem alloc of simply returning VM, like basically what we had before. And that is the thing, this was reviewed, this past review probably reviewed by 100, if not 1,000, probably not 1,000, probably reviewed by dozens of people. And yet we are here, half a year later, discussing SPARC64 instability. And if you review this closely, which obviously nobody else did. I mean, the thing is code review, like, yeah, it's like they moved some stuff around, yeah, there is still GFP kernel, flush, reset, whatnot. It's probably fine, right? So if we review this very carefully, which I have done now because it causes severe memory corruption on SPARC, making the Linux kernel nearly unbootable. I mean, obviously nobody at ARM and IBM has SPARC to test, which maybe is not the best idea, this fast forward and break things development method. So here's SPARC, right? So previously this was vmalloc node range, size 1, vaddress, and GFP kernel, NUMA and stuff. And where was it? Ah, yeah. So look at that. We have here page kernel 0 no node, right? And look at this, the generic code here does VM flush reset permissions. This one single little flag, which was overlooked in code review, which potentially affected also some others. So if this is, I've not read you, so that is the issue, right? They replaced allocating this kernel as this memory here. By the way, MIPS had the same, like maybe that is like, if this is important, they also changed this for MIPS. Oops. Yeah, this is what I criticized for years, this fast forward and not test much. And then the problem is I did not know what they at all tested, right? I only saw every year SPARC became less stable until the point where this year it became nearly impossible. Like previously it was just a little bit unstable. Now it was nearly impossible to boot since some months. And now we bisected this, right? Live on Twitch and YouTube. And yeah, I don't like 20 years later, the argument from Linus Torvalds and all the kernel developers is like, hey, look, like we constantly make our code more amazing and refactor. Like, look, this is so much more clean, refactored, nicer code, which like, yeah, but even with Linux being the most popular operating system now on all of Android and stuff, there are not even with 2048 Linux distributions, there are not enough people to constantly test and bisect this. And the problem is, like, there's so much changing, you basically can't single-step debug through this complex stuff. You need to always bisect this. And that means, like, and then if you have fuzzy bugs of, like, it's crashing sometimes, and there is most likely another bug. So these were the 2 bugs I found with 40 hours. And there are probably more bugs because we sometimes still see some issues. And Debian developer said, since 4.19, I think they said it's just locking up, right? Don't bisecting, rather like, yeah, Debian developers. That's not an issue with bisecting. It's just everyone is rather time constrained, like for years, and they're happy that I debug it. But they also said here, not sure. Yeah, so they say the kernel crashes completely, which I think there's another bug because I still see that the TG3 Ethernet sometimes dies, at least or like on the like machines that have a Sun TG3, and I've not yet 6+ hours of uptime. Like the new kernel is more amazing. You can run 3D graphic and stuff, usually at least. And I mean, we have a list of more bugs. Like my to-do list grew to 689 entries now, including ALSA endiness things not working, just working by default and stuff. But this amount is just crazy, right? In my opinion, yeah, sure. And I've not yet debugged, so I would need to study the SPARC memory allocation stuff, which also somewhat is not my job, right? What the SPARC kernel does differently with VM flush reset pumps. The thing is, this I cannot that cleanly revert because there were many more changes since then, but I fixed it anyway. So as you see here, so this patch, literally the next commit changes this code further, as you can study yourself if you want. Arch convert remaining overrides and stuff here, right? So like literally the next commits immediately make it not revertible. However, given that I debugged that for real, there is a simple fix. So and that is the other one, hotfix SPARC64 of, yeah. given that this is the only issue, I propose for now, until we further debug that, thanks to your patronage and YouTube subscription and stuff. I mean, maybe that is a completely correct behavior, and there are very valid reasons for TLB optimization, flushing and whatnot. It's not entirely clear why this VM flush reset permission thing here causes this memory corruption, but it does. Like severe memory corruption, not just a little bit. And obviously this is, maybe it causes similar memory corruption than the mount option handling, just that we load way more modules, so probably for all the pages loaded by modules, which in many Linux distributions are many, like X4, BetterFS, Ethernet, Radeon, like easily dozens of modules loaded on boot, right? From the name, it sounds like, yeah, some VM flush permission thing probably should be fine, but apparently it isn't. Maybe, I'm speculating here, maybe in the kernel, the code running in modules should not have TLB for translation local site buffer, for the memory page handling, performance optimization, and in kernel, like for decades, in kernel, basically scratchpad memory permission registers, basically translation local site buffers. So yeah, scratchpad buffers. Maybe in kernel they should not be flushed and whatnot. Like the results are as shown, right? So this is literally the result, and this is also why UDEF ADM shows here, because that is loading the module. So this is basically a false positive of like, yeah, UDEF ADM caused it. Like this is also diagnostics and reading, because so many people like UDEF ADM and systemd. It's like, no, like if your kernel is corrupting its own executable memory management stuff, then it's not UDEF's fault. It's also not like modprobe's fault. Usually there would be, decades ago, there would be modprobe, which, hey, it would be more readable, right? But now UDEF, systemd, they link in libkmod and stuff, so it shows as UDEF or systemd instead of modprobe, which might potentially have been more meaningful. But anyway, yeah, just wanted to present you this. Thank you again for ARM and IBM for allowing us to create YouTube content and debug that with you. If you want to see more of this stuff, leave in the comments below, share, like, and subscribe to join with this live. I will, of course, now commit this and help the Debian people also to have a more stable kernel. More bisecting probably required. The other bisecting, most likely even more time wasting, because like if other stuff, like if other page, table, translation, local site, buffer, corruption things are present even longer, and this stuff breaks it even more in between. And that was also the problem with my bisecting here, right? Like bisecting this, like between bisecting various other bugs and things that at times were fixed and whatnot and unrelated and so on. Like, yeah, it needs extreme concentration and dedication to do this for 40 hours. 20 hours here, 20 hours there, and 8 hours there and stuff, right? You have seen this on Twitch, right? And I so often said, we need to be careful. Is this the same bug? No, it is not. And even then, I probably at least 2 times went like bisecting means binary partitioning the problem space of like between that commit and that commit, it changed and got worse or better and whatnot. And sometimes I went into the wrong partition, like took the wrong turn with this binary partitioning thing, went into the wrong binary partition and spent 2, 3, 4 hours. It's like, dude, there's not even, we don't even have a result, right? Anyway, that's it. We do this for SPARC only, although theoretically maybe I should do this for MIPS as well. We could actually check here, and thanks for this anniversary. Why is it 10-year anniversary question? 10, not sure why there's 10. Yeah, highly appreciate this. Quick question. Do you have any thought, advice on how to monetize open source work for a living? Hey, I struggle myself, right? The only thing is, for decades, nearly nobody wanted to pay me. It is challenging. I probably put, I mean, beside not, the problem is not everyone can run a YouTube channel, right? And Twitch. It is also not the most effective thing. I only do this because I also want to educate and share and so on. Like if it would not be, I do this for education and sharing and experience and T2 development and discussion. Also, I see so many other, like in the meantime, we are still not a big YouTuber, but a aspiring, growing YouTuber. And if YouTube and Twitch live streaming is not your passion, probably don't even start it. I mean, hey, I got swatted the other week, like so much to, maybe you don't even want to put out yourself so much. And I see so many YouTubers that are obviously way smaller than I, open source developers, like it doesn't scale either, right? So not everyone can do YouTube and Twitch, and not everyone can do everything and whatnot. I would suggest really putting sponsorship things out there now, but even for me, it took 5 years on YouTube and Twitch. I don't want to overemphasize that this works. I basically, my short story is I've still not found the best way, but like 5 years live on Twitch and YouTube, I know, I mean, I can still not live of it, right? It's still an unsuccessful tiny little hobby that I do to grow and at least have something, and being able to focus more on finding 4 or 2 year old or 6 months old bugs here. But basically put sponsor links everywhere. Like I did this even, like, I'm not saying it works the greatest. I mean, obviously it doesn't work the greatest. Even KD and GNOME struggle and stuff. I would say we also, like, basically we need to rethink this, but basically we are at T2, of course, at T2 Linux, the superior Linux distribution. We, of course, we are only doing it a little bit, right? Other people like Big Name, Ubuntu and stuff, they would here sign by email address and really click, like yes, no, and like we do it very, very lightly, right? Hey, you can sponsor, right? Just continue to download and stuff, right? Sure, our website is not the greatest and so on. Yes, I know. And you could integrate this more if you wanted. Maybe try to engage with companies that use your stuff and so on, or just speak up and advertise for better open source compensation. And there was recently a study by some companies that came to the conclusion that most open source developers consider to stop and are overworked and underpaid and stuff. So it's a common thing, and I've still not really solved it, but we're working on it. And if you have any other input on that and suggestions, always comment below. And also, I would say, don't try to do perfect software, giving it away for free and earn by documentation or other stuff. Like, as the Blender 3D modeling foundation has shown, or company has shown, that went probably bankrupt 20 years ago, and now it's the Blender foundation thing. Making an amazing software and just earning money with documentation doesn't work. I probably nearly nobody was successful with this. So I would suggest some directly, hey, like we really want to live off of this and would be really cool if you regularly sponsor this stuff. Anyway, where were we? Oh, right. We could review Execmem. So basically, all we need to do is now that we know that this is a bug, like here's, for example, long arch, and that's hopefully not buggy. So basically, what we would need to do in this change, we basically would need to polish. This was IBM's work. We basically would need to review IBM's work here and basically read here every line. So that is MIPS. Oh, wait a second. MIPS was. Did I say MIPS? No, MIPS was. Yeah, MIPS. Wait. Wait, this was 0. So they changed, like, basically. So I don't have long arch. Like, if the Chinese CCP wants to send me long arch, I'm happy to test that, or like on QEMU. I mean, theoretically, we could, like, maybe for MIPS it doesn't have an effect, like. But they also had 0 here, right? Like, so theoretically, it could potentially affect this. So as you see in Neos, you see Neos 2 had VM flush reset perms here. So, I mean, I booted SGI02 and Octane recently. It didn't immediately show. PA risk also, but look at that. PA risk had, using read, write, execute means less protection for modules, but it's easier than trying to map the text data in it and correctly. So, for example, this is probably also broken or not. We had here, no, wait, no, this is the next, sorry, kernel You see, that is a different, it's like, yeah, just easy, like just change all the stuff and then everything is broken. Kernel, do we even look at the right thing? Page kernel. Oh no, there is page kernel. Oh, sorry. No, this went here. Sorry. So this is between this. Okay, so this. Okay, so then let's review this once more again. Okay, they had this here, and this is probably how this was overlooked, right? So this was 0, and it's so. Yeah, page kernel. Yeah, page. Yeah. So that really changed. Long arch, as I said. MIPS really changed. That was 0. Now it's flush reset, right? Here it was VM flush reset, so that Neos 2 should be fine. PARIS was 0. Now it's like PARIS could also be affected. Like next time we boot, PARIS could also be less stable. I don't know. It certainly depends what the architecture does with TLB flushes, what precisely happens there. So RISC-V had this, so here's VM flush reset perms, so that was there, so that's not broken. Theoretically in our patch, like here is, I mean, we could keep it in mind, like maybe we only patch where we see something to better track upstream. Here's our SPARC, so that is affected, right? So that is then changing, as you see here, conveniently in the next file to VM flush reset perms. So this is how easy, just another reminder how easy this constantly changing, the only constant is change and regressions, how easily stuff is broken, and this accumulates, like as seen with PS3, right? They clean and refactor, they miss offsets, and so on. Even GCC, PowerPC, right? They miss ITVEC. Missed an ITVEC bit, took me nearly 4 years to get upstream this GCC. And this is how, not only in Windows and Mac OS with #peakbugs, but even in the open source Linux world, stuff is constantly changing and accumulating more bugs. And how many developers between Debian and T2 it needs, and 8 hours a day, 9 to 5, and sometimes a night to debug through all of this. Amazing how many people tuned in. That is amazing. Let's quickly scroll through. Sorry, through here. Still was a little bit coldish there. Thanks for maintaining the kernel. Happy to see you all. Thank you for that. Happy you're back. Doing well. Thanks. I love you. Thanks for not censoring selfish views and personal stories. This is swatting story. Amazing day. No kernel. Yeah, I mean, there is a kernel debugger for some architectures and stuff, but like if stuff randomly corrupts, there's not like, the problem is also like it happens with so many page allocations and stuff, you're not kernel debugging translation look-aside buffer. Like basically this, you need to gather a lot of statistical data and pinpoint lots of stack traces and stuff to find rebugs there. Testing mere plot. Yeah, I mean, that's the thing. I understand they want to develop forward. I understand SPARC is not the most popular architecture. Potentially they could have broken some more. I mean, it could be caught in review, but didn't. But that's also like everyone at IBM and ARM, they are also only humans and they also only cook with water. And that is how bugs happen and accumulate. Did I show you the fix? I showed you the fix, right? So the fixes that we do in T2 is like this. We do, here's VM flush reset pumps, right? I remove this default to 0, and like if not SPARC, then basically patch this away for now. Like basically sometimes something like this could get upstream. This is by the way also why this revert does not apply, because as you've seen in the actual commit, this looks different, because just in the next commit they clean this up further. This is why I couldn't even test this with the next patch reverted, because literally the next patch also changes this, right? You see here, this was open coded just in the code here somewhere here, and then they changed it, right? This is why this is slightly different. Something like this could be like this could, in my opinion, be upstreamable. You could also duplicate this line, like if you want this, I mean, it's not even modified, this basically could be const if you wanted to, but it does also not really matter the most. The compiler likely optimizes that to one assignment either way. But if the kernel developers extremely exist that you could duplicate this line like if diff spark and initializes to 0 or reset perms. I guess I should more regularly use O2 and see if that is a problem there too. Maybe this also shows that there is a bug in the SPARC memory management subsystem in some way, shape or form, TLB flushes, but that is for others or another day. Others talk, you do. See other distributions knowing it didn't work, just... Yeah, that is the thing, right? And then they complain about me like, this dumb German YouTuber only complaining on YouTube. It's like, if you would know how much time I spent here and then other distributions, like, yeah, Tdo is not worthy. It's like, yeah. Anyway, TLB flush in every context, swap isn't TLB. That is certainly highly optimized, and no, it isn't. This is why usually you have. This is why usually there is the Linux kernel optimizes this, so it's not fully flushed, and most kernels optimize this. So that is why on x86 that is why usually the address spaces are kept different. And here, for example, there is address space Linux kernel documentation, newer, older, and this is why, and not to flush this as a huge performance optimization, we had this 32-bit 3 GB. Those who are that old remember, there is only 3 GB usable on 32-bit platforms, exactly for that reason. Or I think they recently with Spectre and Meltdown some years ago, I believe they changed this to 1 GB by default, unless you use HiMem, for probably TLB flushing security reasons, to have more space and gaps and stuff probably. And that is the split, right? Like do we have here 0, 4, wherever that is. I thought it's mentioned here about whatever. Do we have some nice graphic maybe on Wikipedia? So you don't want to flush this that much. For performance reasons, that is of course then the hardware needs to walk the page tree again, and that is exactly what it is meant for caching and translation local site buffering, and that is why usually you here like kernel page table isolation, which you would see if there's even Wikipedia. There we have that in larger, right? So that is why that is kept separately. If you would flush it completely on each context switch, you could use 4 GB or nearly 4 GB on 32-bit, for example, but you can't. And yeah, on some architectures that's even hard coded. I believe on MIPS it was pretty hard coded for really annoying reasons. And you have done an amazing job, Spark. Happy to hear that. So bleeding edge, so this is a bleeding edge and we love it. Okay, we have been there, seen kernels mostly written in C. It's hard to beat C for Linux kernel devs. Or good code can be written in any syntax. Yeah, you could basically, like this bugs, people always like, Rust will make everything better. Like this bug will have, literally would be identical in Rust, right? Like if you assign the wrong flags, Rust will not magically fix all bugs. Like if you compare password wrong, you will have a simple authentication bypass. Like if you check this password null pointer or whatnot, it's like, yeah. Or if you assign the wrong flags, you assign the wrong flags, right? Nothing in Rust will stop you doing that unless you want to write driver code optimization. Have a good evening, you too. Midi wrote there, don't do it for the money. For the question, I think this is not a fair thing to say. We cannot all live from code and bugs and documentation and thanks, stars and good wishes, right? It is crazy that the billionaires take out most of the money, right? Even use open source for free in all their big fang mega corporation things, and open source developers should code for world peace and not the money. We somehow need to change it. I don't have the best solution, but happy to read your comments, shares, like and subscribes. Good old post terminal, want to try T2 and give it a spin tonight. Happy to hear that, that's amazing. Please report back. We will continue. So we will continue on Twitch. I have some more things to do. So don't forget to also take a look at Twitch. That is for free as well, except the archive. To motivate you, donate $1 there, and we can improve some T2 things. Basically fixing my own bug because recently introduced some bugs myself. Comment there, Anonymous, did the Rust SWAT unit show up already? I don't like the Rust, like one last thing to the SWAT thing, it's of course totally not funny, and I don't like the Rust or other see whatnot jokes. I don't believe it's Rust people. I mean, it could be, but I would like it. It's silly and childish to make Rust jokes. I'm no sane person if I criticize. I mean, I didn't even say Rust is complete garbage. I said like Rust has ecosystem problems, and the ecosystem is tearing Rust down or holding Rust back, and it's not convenient to work with, and anti-distribution Linux packaging. No sane, mentally stable person would do that. That I have like no idea who did this. It makes no sense to speculate. It could basically be everyone from far right, from Russia. It is more likely someone far right Russia or just some low IQ script kiddie than obviously Rust or other Linux distribution developers. It is, but anyway, I don't know. If you know, let me know. I've doubt they will ever be found. So that is why usually we know live stream from the space station, from abandoned NSA listening posts or other random places, just for fun and not be swatted. That's it for this video. I hope you enjoyed this, learned something. This is what it takes to hunt all these bugs. Like basically my to-do is 668 lines long, and plus all those bugs. And what also people often forget is all the people applauding this like changes is like they don't see. And even the bigger corporations, then they wonder why the data center is unstable. Sure, they don't run this usually on SPARC these days, but it could break RISC-V, MIPS, whatnot, right? So, and multiply this with all the other bugs. If you in the Linux kernel constantly see like fixed this stuff, and that is why we like, it's not like fix use after free, it's like incorrect free IRQ sequence, it's like people always like vintage and retro. No, this, in my opinion, we should not develop like this. Kernel should be much more stable. Maybe change like Q API changes and like a decade, and then like Windows and Mac OS between version 2 and 3 and 4 and 5, and not every day, because that is what the kernel developers do daily, breaking APIs and like in-kernel APIs of IRQs and exec memory zones and stuff, and PlayStation 3 cleanups and similar such multi-queue block layer and other improvements. I understand improvements and stuff, but hey, you all, like maybe queue this in a major version and not break it weekly, daily, and every minor version. Anyway, that's it for this video. Maybe come over to Twitch, we have some other things to do. Hope you enjoyed to learn something, and to see you soon for the next fun stuff and fixes, bisecting, and so on. And necessities for vintage and retro risk living.